Ajeet as our next speaker. I appreciate you taking the time to put something together for us, and a great topic at that. So it's my distinct pleasure to introduce my co-host, Ajeet Reina, who is the Developer Relations Manager for Redis Labs. Ajeet is also the leader of the world's largest Docker Meetup community. He has written over 250 blogs, and he's an award-winning Docker captain, founder of Collabnix. And Ajeet's worked as a solution architect, an IT consultant, systems engineer, and product advisor. And he's really used his gifts and talents to benefit his fellow technologists in the Bangalore community and really also globally. So today, he will speak to us on extending Docker and Kubernetes K3s to IoT Edge. And without any further ado, we'll turn it over to you.
Thank you, Ari. So just need one confirmation. Can you see my full screen?
Let's see. Now I can, yes.
Okay, thank you, Ari. Okay, fine. So hello, everyone. Thank you so much for being with us till now. I know that there has been a lot of great speaker lineup, who are talking about DevOps, and then Docker, and then Azure, and a lot of other stuffs related to the DevOps and DevSecOps. So today I bring you a very interesting topic on delivering a Docker on K3s to IoT Edge device. So this year I have been working very heavily on IoT Edge devices. So without any further delay, let me go ahead, share you an experience. And this is going to be very lightweight talk. So hopefully it should be interesting for you guys. So a little about myself. I am a Docker captain as well as an ARM innovator. So there are around 35 to 40 ARM innovators today. ARM innovators are those community members who goes ahead and play around with the ARM devices. So I have been actively working with few of the ARM innovators in building very exciting stuffs around IoT. I am author at Collabnix.com. Collabnix is my personal blogging site, which I started writing in 2013. There are around 250 plus blogs, which I have written on Docker, Kubernetes, cloud, DevOps, and IoT. I'm also a Docker community leader. I have been managing a huge community here in Bangalore, as well as conducting events like OSConf, Open Source Community Conference. My full-time job is at Redis Labs. I'm a developer relations manager at Redis Labs. I have been, growing the Redis developer community. So if you go to developer.redislabs.com, I am right now full-time into it, adding more and more content for the Redis community. In the past, I have worked in Dell, VMware, and CGI. I was with Dell for around 8.5 years, working in a bunch of very exciting stuffs around Docker and the solutions like system management tools on top of Dell servers. Let's talk about cloud native on IoT. Now, we have been talking about cloud native applications, but how does this cloud native looks like on IoT Edge device? Primarily, I am going to choose a Jetson Nano board. This is an IoT Edge device. The reason being, Jetson Nano today brings the cloud native to the edge. And now, what does it mean? Now, if you look at the cloud native, it is not just about containers, okay? It is all about DevOps. It's more about how you, how you deploy the application rather than where you deploy the application. And this cloud native application could be a DevOps. It could be in terms of containers. It could be in terms of CI/CD platform. So right now, if you ask me, which is one IoT Edge device which brings the cloud native to the edge, and the answer is Jetson Nano. This is like a $59 small IoT, a tiny like credit card size device which can fit into your pocket, and you can run an AI workload on top of it. Isn't it interesting? So now when we talk about Jetson Nano, right, today we have a support of Docker on Jetson Nano device. Now, for many of you, you might be knowing about Raspberry Pi. So think of it as like it's a big brother of Raspberry Pi with GPU inbuilt on top of it. And during this talk, I am going to show you when you get started with the Jetson Nano board, what are the things which are supported today? Because it does matter when you can purchase this $59 device and start running containers on top of it. Now, one of the main thing when you talk about Jetson Nano is the Jetpack. Now, Jetpack is basically it is a software which gets installed on top of it. It is basically shipped with the SD card image of Jetson Nano, and it comes with NVIDIA container runtime with Docker integration, enabling the GPU accelerated containerized application on Jetson platform itself, which means that today developers can package their application on Jetson with all the dependencies. Now, this is how the Jetson Nano looks like. So if you are seeing it for the first time, it's a complete computer system itself. So think of it as like it's a complete laptop which has USB drives, and you have an HDMI port, and even USB 3.0. Like you can expect a high speed out of it. You have a GPU card into it, micro SD card slot. Now, a micro SD card slot is just like a hard disk for your laptop, right? So it's same way you can use like 128, 256 GB of micro SD card, and you can install, run a complete operating system on top of it. Okay, so Jetson Nano today comes in two variants. One is 2 GB and 4 GB. The 2 GB cost around $59 and 4 GB cost around $99. Now, talking about the Jetson software for AI edge device. Now, when you buy this product and when you use the SD card image, it basically comes with the stack, the software stack, and the overall boxes which you see here, the Tensor RT, powering the deep learning, computer vision, accelerated computing. These are basically nothing but containers. So these are in the form of the containers which is shipped by NVIDIA to you, which means that for an AI computer to be AI compliant and to be sufficient enough to run the AI workload, you have all those containers running on top of the Jetson device. And with that, you can do all the deep learning stuff like object detection, pose estimation, path planning. You can see basically the path tracker, right? How the object has been moving. And DeepStream is more like a deep learning platform. It is like a real-time streaming which is provided in terms of the containers. Okay, so this is how the Jetson software on top of AI edge device looks like. Now, to get started, what do you need? You need an SD card, you need a USB keyboard and mouse, computer display, micro USB power supply. So the power supply has to be like 5 volt, 4 ampere to get it up and running. And then you have an SD card image which you can download it from here. Now, to start looking at the first and foremost thing, there are two components which I'm going to talk about. The first thing is the Docker, and the second thing is the K3s. So let's talk about the Docker. Now, the Docker support for NVIDIA Jetson Nano comes by default. Now, this is really interesting. Today, if you talk about Raspberry Pi, you have to go ahead, install Docker on top of it, even though it is officially supported. But if you have an SD card image, if you flash it on Jetson, the Docker comes by default. And the another interesting fact is you have 20.10.2, which is the very latest version of Docker, which is shipped. So just keep that in mind, because you save a lot of your time in compiling the Docker itself, right, on top of the Jetson Nano. The second thing is, if you want to install the latest version of Docker, the way how you do it, you install the latest version of Docker with this curl command, enable the NVIDIA container toolkit with this sets of command, and then you have to install a very, very important package, which is called as NVIDIA Docker 2. Now, this is the package which basically helps you your containers to use all those NVIDIA drivers, which is in the Jetson Nano, right? All those drivers are compiled so that your containers can talk to your hardware. And simply you can go and say Docker run ARM64 v8. This is an architecture. This is the name of the Docker image repository, and then Ubuntu, and you can just run it as the usual you run it on your laptop. Docker Compose support for NVIDIA. Now, this is one of the feature requests which I raised in 2019 at I think in the month of March, April, and I'm really excited to share that now we have support of Docker Compose for NVIDIA Jetson Nano. All you need to do right now is you have to go ahead, install the softwares, and follow these steps. So it needs libSSL dev and libhdf5 dev so to be installed on top of it. And as you can see here, I have 1.26.2 Docker Compose version, which is installed on top of Jetson Nano. Now you have a Jetson Nano, and Jetson Nano comes with a GPU device. Now how your containers are going to talk to the GPU device through Docker Compose, and this is how you have to specify the YAML file. So Compose services can define your GPU device reservation by specifying the services like the test, where I'm specifying, okay, NVIDIA SMI is a command, okay, which works really great with CUDA. And a CUDA is like an API, how the Docker containers or how you are going to talk to just like a web services. Like when you talk to any hardware, there should be some API, right? Like for the x86 Dell servers, which I can say there is the API called as Redfish API. In the same way, we have a CUDA as an API, which allows you to go ahead and talk to the hardware. So the way how you define is, this is a compose, how it looks like, and you just have to go and say Docker compose up, and your services are going to now use the GPU. Now, with the latest release, the CUDA 11, I noticed that NVIDIA SMI is no longer available. So if you are following my blogs, so if you go to the Google and type Docker Jetson Nano, so the second link which you get points you to my blog, which might not work today. The reason being, with the latest release, NVIDIA SMI is not shipped with the Ubuntu. You can use a tool like JTOP. So you can use Ajeet /Jetson stats nano as a Docker image and run JTOP, and you will get a real-time statistic of your CPU, GPUs, and the disk. Now you can check the Jetson CUDA information. As I said, it's an API to talk to the GPU devices. You can use the Jetson info, Jetson utilities GitHub repo, where they have a Python script which displays all the CUDA, OpenCV, TensorRT, VisionWorks. So right now, do remember that there is no support of CUDA 11 for Jetson board as of now. So we need to wait till NVIDIA goes ahead and releases that. The CUDA compiler and libraries, if you want to really go ahead and install the latest version, this is how you need to run it. NVCC was earlier, you would be able to run it, but in the recent NVIDIA SD card image, which you see that this particular tool has to be enabled, or the modules has to be loaded. Now, this is interesting, but how shall I build those apps from the scratch, right? And this is where your generic Docker workflow comes into the picture. So if you look at the Docker, so usually the workflow is build, ship, and run. As a developer, you sit on your laptop, you build some application, push it to the Docker hub, and that get pushed. That can be pulled by your customer to go ahead and run it, right? So think of it, for example, the Hello World example, Docker run Hello World, and it runs really great because this particular Docker image is right there on the Docker hub. And the reason why it is working on your x86 hardware is, if you run m platform mquery Docker image, you will see that it supports Linux AMD 64. And that is the reason this is basically a Docker image which you can use on any of the image which you are trying to build, whether it supports this platform or not. But think of a scenario where you as a developer sitting on your laptop, building an application, and then try to deploy it on the edge device. That is not going to work. The reason being, this particular image has not built for the ARM devices, the ARM architecture. And in the same way, if you try to run Hello World, the Hello World is able to run on those Jetson devices. The reason being, if you go and try to run m platform mquery on the Hello World, you will see that the Hello World image, Docker image, which is like quite a popular Docker image, has been built on all this platform, AMD, ARM, V7, V8. These are like a different architecture. So think of it as like the Raspberry Pi, it comes with the V7 and V8. So V8 is for the Jetson Nano. So they are different architecture, the ARM architecture built for the certain specific hardware. And the reason why it is working, because it supports all those platforms. Even it runs on Windows, because if you see here, we have Windows AMD 64. Now, the question would be, do I need an ARM devices to build ARM-based images? Not necessarily. Sitting on your Apple MacBook, you can build the ARM images? And the answer is BuildX. Now, BuildX is a CLI plugin which helps you to build a multi-architecture Docker images. So if you look at the command docker buildx build, and you specify the platform as ARM v7, v8, and it is going to go ahead and build those kind of images. So sitting on your laptop, you build that image, and then that can be pushed to your IoT Edge device. Think of it as like when we are talking about the cloud native application, like any developer who is building an application doesn't have to be on Raspberry Pi, or you don't have to go to the cloud and bring up all those architecture to build up this application, right? So whether on your laptop or in a cloud, you can use the same docker buildx command to build those images and then push it to all your edge devices. Now let's move to the next topic, which is K3s. Definitely K3s is a lightweight Kubernetes which you run on IoT Edge device. The reason being, if you run a full-fledged Kubernetes distribution, it is going to be heavy for the IoT device because of the less resources. We don't need to install gigs and gigs of different application related or different Kubernetes tools. So K3 is a fully compliant certified Kubernetes distribution. It is really easy to install. So you can see here, you just have to use the curl command, get k3s.io, and then use the sh command, and it's done. And when you add a worker node, you just have to give the token. You have to supply the token to it. That's it. Today, so K3s works with a different backend storage like etcd, MySQL, Postgres. It works. It has been well tested. And the interesting fact is the complete binary is less than 100 MB, right? So it's quite less, especially when you have an SD card image of around 64 GB or 128 GB, and if you want to run a heavy workload, right? Even the NVIDIA, most of the images which you see, the deep streaming and all this thing, they are like a gigs and gigs, right? So in that case, when you have an orchestration engine running on your Jetson Nano, which is less than 100 MB, it matters a lot. Now, the most important thing which you really need to understand that K3s support both Docker and Containerd. Okay, so this is really important. So you might see a few of the blogs which have been written primarily on the Containerd or Docker, but right now you can plug and play. And in this one of the example, a screenshot which I'm going to show you, it shows you like how you use the pods with Containerd as well as the Docker. So if you want to run a deviceQuery, okay, deviceQuery is again a kind of a CLI which queries the device, whether the GPU is available or not, and all this thing. So running a deviceQuery on Docker with GPU support, you have to go ahead, use this Docker file. So what has an NVIDIA done to the SD card image is when you flash the SD card image, there is a directory under temp samples utilities. So starting from 1 to 5, there are different utilities. So deviceQuery is one utility, and all you have to do is go ahead and they say put it in a Docker file and try to build it. So if you see here, Ajeet Rena /Jetson_ deviceQuery is a Docker image, and you can specify the Docker file. And once you do that, all you have to do is say Docker run and supply the runtime as NVIDIA. Either if you have already passed that variable into your daemon.json, then you don't really have to do it. But I would recommend to go ahead and pass runtime NVIDIA so that you can expect the right results. So once you run this, it basically find out the devices. So here the device 0. So we have the GPU device. It has identified as NVIDIA Tegra X1. Now the same thing if you want to do with the Containerd. So this is how it looks like. Like you can create a bash script and you have a CTR rather than using the Docker command, right? So you can use the Containerd to go ahead and you can specify the GPU's 0, right? It has been tested. It has, so Containerd today identifies the GPU. So you can do that. And now the next part would be how to run this deviceQuery as a pod on K3's cluster. And this is how it looks like. So this is a YAML file where you specify the metadata as deviceQuery. You specify the container information. The name of the container is NVIDIA, the image, whatever we built in our last slide. I'm going to do that and then just run deviceQuery. And all you have to do is, if you have a K3s, you just say kubectl, kubectl apply, and it's done. And this is how it looks like, where I'm just describing the pod of the device query. Now, let us look at the real-time implementation examples where the Docker and K3s has been used. So one of the interesting example which I can look into it is, I have been working as a smart camera system building it. So if you look at the Jetson Nano device itself, we have three major component parts. One is sensors, one is GPU, and one is a camera module. And how you are going to all these three components can be accessed using a Docker or containerd, right? So this is a smart camera system for real-time crowd mask detection. In the COVID situation, definitely think of it as like you are a mall owner where a lot of people are coming in, and you just want to track like how many people are really wearing the mask, right? So this is one of the use cases which I took. So the mask detection system, what do you need? You need a Jetson Nano board and a camera module, right? It could be a USB camera, or it could be just like a file which you can pass to the basically Docker container. So if you see here a Jetson Nano dev kit, which you need a Jetpack 441. You have a power supply, you have a USB webcam has been used, and then another computer which basically has access to the VLC. So it get exposed to the certain port like 8554. So if you have a Jetson Nano, you flash the SD card image, and all you have to do is connect your camera and run this command: Docker run runtime NVIDIA privileged. So right now you can also, there are certain Linux capabilities, kernel capabilities, you can use the capabilities to here. And then you pass an environmental variable where you pass the Jetson IP address, and you can even run it from your laptop itself, right? And then there are certain ports which have been exposed. And once you run this, then most probably this is something, let me show you one example here. So this example shows you that it's a Dubai mall, and the people are passing in, and I'm just trying to track the wearing the mask. So I have passed a file instead of the camera here. Okay, and the interesting fact is it will track how many people are really wearing the mask or not. Just with one Docker container, this application is running on Jetson with a camera module connected. And the interesting fact is it is calculating how many unique people are wearing the mask itself. And if it is not visible, it says not visible. So it's all about AI. It's all about IoT Edge device. It's all about bringing the container native, cloud native technology like Docker. And the same has been tested with K3s when you run it as a pod. The same image which you can use it either with a containerd or with a Docker. Now with this, I am going to introduce one of the really interesting stuff which I am working on, which is called as a Cherry bot. So this is the first time I'm talking about it in an open meetup. And this is one of the effort which I started around 6 months back with one of the Python developer. And this is work in progress. So right now, so the whole idea of this robotic platform is basically the different use cases. So it's an AI-powered payload delivery system, which is a low-cost autonomous robot system. It has a Jetson Nano, it has a digital face, it has the GPS module with the camera, the LiDAR sensors. Now, you might be saying like there are so many other bots which are available over the market. Why this? The reason being, all of this application, the first thing is all of this application which will be running for this to control this particular robot will be a containerized application. The second thing, it uses the Jetson Nano, which costs just like $59. So the primarily what it is going to do, it will basically be equipped with the Jetson Nano board, low cost, low powered AI deployed as an edge device. It will be using a deep learning for sure to correctly interpret the data gathered, and then it can identify your objects. So this is just to give you a glimpse. So we are starting with something from the scratch. We are heavily using RoboMaster for our baseline, where you have 4 wheels, and on top of it, we are going to put kind of using a 3D printer. The idea is to get in a compartment over it, and then the Jetson Nano, 2 of the Jetson Nano with 6 cameras. So the whole idea is, so right now we have tested the deep learning platform with it, trying to identify the objects, but there is still a lot of work to be done. Primarily, the use case would be the food delivery, swag distribution, and medicine delivery. So think of it as like you are in a university where you want to parcel a food and within the premises. So the Cherry bot is going to deliver the food for you. If you are in a conference and you want to distribute the swag, so Cherry bot is going to help you in distributing the swag. And think of it as like when you have a touchless medicine delivery system within your apartment or in a hospital. So the Cherry bot will be the one robotic AI or AI powered robotic platform which is going to hand over those medicines to the patients, right? And if you are really interested, I have submitted a CFP for ARM Dev Summit, which is happening in October. So as part of an ARM Innovator, the plan is to go ahead and display this product. So there is still a lot of time to go ahead and work on it. And if you are really interested, do reach out to the Collabnix Slack channel. I am open to collaborate with it, even though there are a few of the parts. So during, trying to build this kind of infrastructure, it always requires, there are a few of the parts, the IoT parts, which you have to get it from China or Dubai. But it has been a challenge because of the COVID reasons and all. But I am happy that we are back into the action, and definitely maybe in our upcoming meetup, I am going to talk about full end-to-end, solution, like how we build this interesting AI-enabled robotic platform. So with this, I think I finished before the time. So let me jump back and try to see if we have any question. Ari, are you there? Okay. Yeah.
Yes, I am. Well, you know what? I did not. I think people were so focused on the interesting topic that you spoke about that honestly, the chat has been silent. But I think it was out of amazement at some of the things you shared. But if anybody now has some questions they'd like to ask, now would be the time to drop it in the chat.
So meanwhile, let me